Hi everyone, my name is Abby, and today we're going to go through the X23 Winter 23 Exam 2. So we'll go through all the multiple choice, all the free response, explain why every answer is what it is, and hopefully this will help in your studying for Exam 2. A little bit about the logistics of the exam. All of the resources you have to study are the same. Everything that you need to bring to the exam is the same. So you can bring your note card, make sure you bring your M card, put your unique name on all the pages of the exam, etc. All the stuff you did for exam 2 is going to be the same for exam 1. So just do the same thing and you should be all right. With that, I will share my screen so we can get started. Okay, cool. So let's get started with the multiple choice. So question 1 is, which of the following about C++ arrays is true? And answer A is that an array can be of any data type. Now I know that this is true. I can have an array of strings, ints, doesn't matter what data type, but I'm going to star that and then we'll explain why the rest of the answers are not true. So answer B is that different elements of an array can be of different data types. And I know that this is not true. This is why we specifically put whatever the data type of our array is going to be. All the elements of the array have to be the same data type. We specify that in the declaration. So I know that B is not going to be true. And then C is that the number of elements of an array can be changed after declaration. And I also know that this is not true because whenever we are declaring our arrays, we're also explicitly specifying whatever the size is going to be, and we can't change it after that. So C is also not going to be true. And then D is that the length function will return how many elements are in an array, and this is not true. It is the size function. So A is going to be the correct answer here for question 1. Question 2 is, what is the definition of implicit bias? And our two options are A, a bias that actively affects your thoughts and has no effect on your actions, and B, a bias that you are not aware of consciously, but that affects your thoughts and actions anyways. And B is the correct answer here. Implicit biases do have effects on our actions, no matter if that's the intent or not. So B is going to be the right answer here. Question 3, given the following code, which expressions can be used to detect if there was an error while reading input from the file? And then in this little code snippet, we are creating an if stream called read file, and then opening the text file grid2.txt. And then we're creating an integer variable called row that we're setting to 0, and then a char variable called call that we're setting to the char c. And then we are reading using read file, the row and the column variables. And then we have a little thing down here that says if something, there was an error in reading. And the question is asking us which expression can be used to detect if there was an error while reading input from the file. So let's go through our answers. So A is readfile.clear, and that's not going to necessarily tell us anything about the stream state. It's just going to reset them all to whatever their default is. So like readfile.good would be true, and then .bad and .fail would be false. So clear isn't going to actually tell us anything about whether or not there was an error in reading. And then B is readfile.good, which is a stream flag that we can use to check the state. But if we look at our if statement here, we would be checking if readfile.good, and that would be checking basically that the stream was in a good state. And that's not going to tell us that there was an error in reading. So that's not going to work here. And then answer C is readfile.reset. I don't think this is an actual function that we can use with readfile. It's definitely not one that's taught in this class. So I can go ahead and rule that out there. And then our last option is readfile.fail. And that would be checking that the stream was in a fail state, which is what we want to do. So the answer here is going to be D. Okay, moving on to question 4. If the string data type is implemented as a class in C++, and given the following code snippet in the main function, which of the following must be true about length? And they give us the code that declares a type string variable called word, and it's assigned to the string 183 class. And then it wants us to print word.length and a new line. So our options are that length is a member variable, length is a private member function, length is a public member function, or length could be either a private or a public member function. So I know that length is not going to be a member variable because it's a function. We're able to call it and do some sort of functionality with it. So that's not going to be true. And then B, length is a private member function. If it were a private member function, we wouldn't be able to call it using the dot operator like we did here. So that's not going to be true. C, length is a public member function. I know that this must be true because we are able to call it using the dot operator, and we can use the dot operator to access anything that's public within a class as long as we have the instance. So C is going to be correct here. Question 5, what would the following code snippet print? And it gives us string course equals x183, and then a for loop that is going from I as 2 to less than the course length minus 2, and then incrementing by 1 every time. And then in the code snippet in the for loop, it's setting course at I to course at I plus 2, and then printing the entire string after. So let's go through this code snippet. So first, let's just put I as 2, and then course dot length minus 2. What is the length of the string? The length of the string is 7, so we're going to be going up until 5, and then let's just put course here so that we can modify it. Okay, so whenever we're going through this, first we're starting with I at 2. So it's going to, in our first iteration of this for loop, change whatever is at 2 in the array, which is going to be this C here. Actually, I'm gonna move this down here. I feel like that'll make it easier so that we can actually have this bigger. Okay, so whenever we're looking at index 2 in a string, remember that strings are like arrays of chars, so there's still 0 indexed. So index 2 in this string is going to be this character here, the third one. And then we're going to change that to course at I plus 2, which is index 4. And so that's going to be 0, 1, 2, 3, 4. So we're going to change this C to this 1. And then we are going to move on and iterate I by 1. So we've iterated, I is now 3, and then 3 is less than 5. So we're good to do this again. So let's erase this. And then we're checking now that course at 3 is going to be S. And then we want to set that equal to course at 3 plus 2, which is this 8 character. So we're going to set this S to be this 8. And then move on and increment I again. So now 4 is still less than 5, so we can do this again. So now we're going to be checking that course at 4, which is this 1 character. And we're setting that equal to course at 4 plus 2, which is 6, which is this 3 character. So we're going to set this 1 to be this 3. And then we are incrementing I once more. And now 5 is not less than 5. So we've finished with this for loop. And then this is what course ends up being. So it ends up being EE18383, which is answer C. Okay, question 6. What would the following code snippet print? We have char letter equals B, and then we are printing letter, which is still B minus A. So what we're getting at in this question is going to be, they want you to think about how each of these is going to have an ASCII value. Now on the exam, they'll never ask you specifically about what the value is going to be, But we can think about this as like, we know that A, whatever the ASCII value of A is going to be right one below the ASCII value of B. So then if we're doing B minus A, we're just subtracting the values. And since B is just one more value higher than A, then it's just going to end up printing E, which is 1, because it would just be like one more than the value of A. So they would never like ask you about the actual like value that you're necessarily like, getting from a ASCII character, but just remember that they all have numerical values. That would be important for this exam. Okay, question 7. Consider the following code, which will be used in the next 3 questions, and they give us a grid of chars, and then they give us a for loop, some nested for loops that would print some of the characters from the grid. And then it looks like they're going to ask us what goes there. So question 7 is, what should go in the if statement body at line 10, that's here, to print the characters of the array grid? So if I'm looking at that, I know that we want to print whatever the characters are. And so if we look at our options here, the first 2 options don't actually print anything. We need to use cout. So neither one of these is going to be a correct answer. But then let's decide which of the 2 it's going to be. So both of them look like the correct format. It's a nested for loop and it's a 2-dimensional array. So we do need both sets of square brackets. And then it looks like it's just going to depend on whatever variables we're using to access whatever index we're looking at. And in this case, I see that we're using row and column in our for loop. So I'm going to want to use C because we don't have I and J in this scope. We haven't created those as variables. And then what should go in the if statement condition line 9, which is right here, to print only the text 183. So to do this, let's look at, well, first let's look at the options. So our options are that row is equal to call, and then B is that is alpha at that index, C is that it's not is alpha at that index, and then D is that there's multiple valid answers. So even just looking at the answers, I can kind of discern what it might be, just because we know that 1, 8, and 3 are all numerical characters. So neither of those are going to be alpha. So B, I can say automatically it's going to be ruled out. And then C would be checking not is alpha. But if I look in this grid, I'll see that we also have some other characters like an exclamation mark, some other like just characters that are not alphabetical characters. So C would end up printing more than just 1, 8, and 3. So C is also not going to be a valid answer. So just by looking at that, I've decided that the answer has to be A, but we can check this too. So let's look at all of the indexes that 1, 8, and 3 are at. So if we're looking at our grid up here, we'll see that 1 is at row 0, or wait, that's the other way, row 0 and column 0. So they are the same, so that's okay. And then we're looking at row 1 and column 1 for 8, so that's okay. And then we're looking at row 2 and column 2 for 3. So all of that matches up, and that makes sense for answer A. And then question 9, what should go in the if statement condition at line 9 if we want to print only the text BFF? So it looks like our answers are the same as they were for the previous question. And I know that row equals call gave us the first answer, so I can already rule that out just because that would end up giving us 183, which is not what we want. So then let's look at, we already kind of looked at the characters in this array, but remember that we saw that BFF are the only alphabetical characters. All of the rest of the characters in this grid are going to be some sort of numerical or just like symbolic characters. So we have numbers, but then we also have these 3 symbols here. So if we're checking if it's an alphabetical character, the only 3 characters that we would end up printing are the B, F, and F. So answer B is going to be correct in this case, which is just checking that the character is alphabetical in that spot. Okay, Consider the following buggy function, which will be used in the next 5 questions. So we have function and it gives us RME. It requires nothing. Looks like it's going to ask us what goes in the modifies clause. And then the effects are that it will remove all numerical digits from phrase, and it will return true if any digits were removed and return false otherwise. And then it gives us the code of the function, and it says it's buggy. So it's probably going to ask us something about what the bugs are doing. So question 10 is, which lines of code above introduce a bug or multiple bugs in the function? So let's just look at our answers. So it gives us the lines that we can look at. So that's how I would go about answering this question. So first, A is only not line 3. So line 3 is that string modified equals phrase. And I think this is going to cause a bug because basically what this is doing is setting modified, which I would assume is supposed to hold like the rest of our string once we've like removed all of the integers. That's what that would normally hold. But what this is going to do is set it already to what phrase is going to be. And then if we look later in the code, we'll see that it's adding on to modified, whatever the character that we want to add. So let's say that our phrase is like hi. If we did that and then we get here and we're adding on, it's just going to add on like hi, and then it'll add on that string again. So that is definitely going to introduce a bug here, but I don't want to say it's necessarily A yet, but I'll put a star next to it because we know that there is definitely a bug on line 3. And then B is that it is lines 2, 3, 6, 10, and 14. So let's look at that. First, let's start with line 2. And that is saying that we are creating a bool variable called removed that equals false. So remember that this function is supposed to return true if any digits were removed and return false otherwise. So this variable is going to keep track of whether or not we've removed any integers. So I think that this is fine as a declaration just because we need to use it in there. And we're setting it to true when we remove an integer. So I think that's totally fine. So I can rule out B as the answer here just because line 2 does not have a bug. And then our options now are between A and C. So let's check if there's a bug on line 6. So this one is line 6, removed equals false. So what is this doing? We're in the for loop where we're going from I0 to the phrase length. So we're going to be checking if the character at that index is a digit. So here we go into this if statement if it is not a digit. And so that would be saying that we want to add on that character to our modified string because it is an alphabetical character. But here on line 6, we're setting remove to false, and that is going to give us a bug because we don't want to set remove to false. We already initialized it to false, and then we want to return true if any digits were removed. And like that means that if we ever go into this else statement here, it's going to want to remain true for the rest of it. So if we had some sort of string that like started with an integer and then had characters after it, this removed would be set to false again, and then that would cause buggy behavior because it's supposed to return true if any digits were removed, but because of that line, it's not necessarily going to do that. So I know that there is a bug on line 6 as well, and so C is a valid answer here. And then 11 is, which of the following test cases would expose a bug in the function as written? So A is we have a string, and that string is just the character H, and then we're testing that. I don't think that would expose a bug just because it's not removing any integers, so we would expect this to just return false because we didn't like uncover that behavior that was causing our buggy behavior. So A is not going to be true. We didn't test it with any numbers. And then T1 as 1, 1. Let's go through, I guess. So if it's 1, 1, we're going to go through all of these first 3 characters, and we're going to go through here, and removed will just be false the whole time. And then we'll add on those characters to modified, which would technically be buggy behavior, but that's not what we're checking for here because we're checking to see if it's returning 1 or 0. We're not actually checking what the value of phrase is, so we don't need to worry about that. But then we'll see that next we'll check this 1 and we will remove it, set remove to true. So that's going to be what we would expect the behavior to do. We would expect it to return 1 if a digit was removed, which it was. So B would also not expose a bug here. And then answer C is that we have this string T2, which is 1, 1. And then we're using that in our cout statement. And this is the type of test that I was talking about earlier with it, like some sort of instance that would cause this buggy behavior. Just because, so we would check this 1 first, and we would go into this else statement and set removed to true. And then we would end up checking O next, and that would go into this if statement because it is not a digit. And then here on line 6, where we get to that buggy statement, it's going to set removed to false. And then it's just going to stay false for the rest of them because those are also not digits. And remember that we want to return true if any digits were removed. So we ended up setting it to true for the first one, but then setting removed to false later. So that is going to return false and give us, it's going to expose that buggy behavior. So C is going to be the correct answer here. Okay. And which statement should go on line 13? Let's go back up. Line 13 is here. So let's see, what have we done in this function so far? We've done the removal. So we still need to do the thing where we remove all numerical digits from phrase, and we were keeping track of that in our modified string. So if we're looking at the answers, we would want to set phrase to what modified was. So A is the correct answer here. And the reason that the other ones are not correct is because B would just set modified to phrase, and phrase would just be like whatever the original string was. So that wouldn't end up like removing anything. So B is not a valid answer. And then C, return modified. If we look back at this function, we're supposed to return a bool, and we'll return true if any digits were removed and false otherwise. So modified is a string, and we can't return that. So we know that A is going to be the correct answer here. And then they ask us, which of the following would fix the bug introduced at line 3? So we have options delete line 3. So what was line 3? Well, we definitely are using modified later in this program. Just because this line is causing the bugs doesn't mean that that's necessarily going to fix it. So we definitely don't want to just delete it since we're using modified later. Option B is to delete line 7. And that would be that modified equals modified plus phrase at I. And that's where we're going to be adding on all of the alphabetical characters, which is essentially like doing the removal of the integers for us. You can think of like the way that this function is working as not necessarily like removing the integers, but it's just only adding the alphabetical characters to our new string. So it's essentially removing them by just not adding them. So we still need this line because otherwise we're not going to be like adding the alphabetical characters to that string. So deleting line 7 is not going to do anything for us here. And then we just talked about why both lines 3 and 7 are important to this program. So that's also going to be false. We don't want to delete both of them. And then option D is to replace line 3 with string modified. So line 3, we talked about how the bug here is that we set it equal to phrase. So if we just remove that part and have just our declaration of the string modified, I think that would fix that bug. So D is going to be correct here, but we can talk through the last one as well. So E is to replace line 7 with phrase plus or equals modified at I. And what that is going to end up doing is just modifying our original phrase, and that's just going to add on those extra characters, the alphabetical ones. So that's also not going to be correct because it would technically remove the like digit from the string, but we would be adding that onto our original string. So the original digit is still going to be there, and then we would just add all of the alphabetical letters again onto the end of that. So that's not going to be a valid answer. And then question 14 is asking us, what is the modifies clause for the RME for the function? So we have that it modifies cout, but we don't use cout in this function, so that is going to be false. And then we can also rule out C from that because we never used cout, and that's still an option there. And then using that same kind of logic, we can also probably rule out D if we just take a look. We never use cin in this function either, so it's not going to modify cin or cout. So we're left with modifies phrase, which does make sense because phrase is our value passed in our parameter by reference, and we are going to end up modifying it because we end up, oh my God, why did it do that? So sorry. Wait, give me 1 second. Technical difficulties. Let me try to just reshare my screen. Okay, sorry, that was weird. Where was I? Oh, I think I was talking about, yeah. So B makes sense because we are modifying the phrase variable. Remember that since it's passed by reference, it's a variable from outside of the function, and it is going to be modified whenever we modify it within the function. And we are doing that once we add that line that we decided that we would add here. So we would add phrase equals modified here, and that would end up modifying the phrase. So B is going to be the correct answer here. Okay, so now we've gotten to the section that is giving us the supplemental section with the puzzle class declaration is relevant to the remaining multiple choice questions. This is something that's pretty common on exam 2. They would probably give you some sort of sheet like on the side or like at the end of the exam or something that gives you like a class declaration. It would give you like pretty much what you would find in the header file with all of like the RME and like the public and private, and it's basically just going to be your big class declaration. So I have that pulled up here, but just like that would be something that you should expect to see like on an exam like this, definitely for the free response, if not for the multiple choice as well. So I'll pull this down for now. So first, 15, which of the following code snippets in main would create an instance of puzzle? So we know that puzzle is our class, and then let's look at what types of constructors we have for it. So by looking at this class declaration, it looks like we only have one, because here we only see one constructor. The next thing is a different function, so that means that there's no other constructor. So we can only use a default constructor here. And so we know that A is not going to be correct because we're not using a default constructor. We're passing in a parameter. And so that is not going to be a valid answer. And then B, puzzle my puzzle. That is a correct way to create a default instance of our class puzzle. So I'll put a star next to it and come back just to rule out the other answers. So C, my puzzle dot puzzle. Remember that we're only able to use the dot operator on an instance of the class, and we haven't actually created an instance of the class yet. That's what we're trying to do here. We can't call the constructor. It just happens whenever we make that instance of the class. So this is not a valid answer. And then D is puzzle my puzzle, and then we're passing in, it looks like the class puzzle. Remember, again, we don't have a non-default constructor, so that doesn't work. But also, I don't think you would ever see an instance of a default or a non-default constructor where you would end up passing in like that class to the non-default constructor, because that would just, I feel like that would just go on and on forever. So that also doesn't make sense. So B would be our correct answer here. Okay, 16. Which of the following creates an array of puzzle instances named puzzle with exactly 5 elements? So let's go through. Puzzle 5. Remember, whenever we declare an array, it needs to be like the data type first, and then the name, and then our size. And this doesn't do that. This is the incorrect syntax. So this is not going to be correct. And then B is kind of like the same thing. We're not using the correct syntax. So we have the class, and then we just have within our square brackets the name that we want it to be. And the size goes within the square brackets. So this is also incorrect. And then C, we're getting a little bit closer. We have our data type and the name and the size. They're just not arranged in the correct place. I'll like write out the way that you want to do it. So it would be like data type, name, size. That's the correct format. So C is getting closer, but we're not quite there yet. So that's not correct. And then D looks like the format that I just wrote out. It has our data type, which is puzzle, the name that we want to call it, which is puzzles, and we want it to have 5 elements. So D looks pretty correct to me, but let's just rule out the last one here. So then puzzles equals puzzle 5. So what this is doing is it would be creating kind of an instance of the puzzle class called puzzles, and then we're setting it equal to some like this isn't even the default constructor, but this doesn't necessarily make an array either. Remember, arrays have square brackets, and just remember that they use this syntax, so this isn't going to be correct. So D will be our correct answer here. "17. Consider the array declaration of type puzzle from the previous problem. How would you print the text of the first element of the array puzzles?" So we have our puzzles array already declared. And then if we wanted to print the text of the first element, let's see. So remember, arrays are 0 indexed. So the first element is going to be whatever is at index 0. So I can already rule out answers B and answer D, because both of those are checking index 1 instead of index 0. And then it looks like our two examples here, or the two possible answers, we're either calling puzzles at 0 with .text or .getText. So immediately what this kind of signals to me, although in general, what I would recommend doing before you like answer any questions like this is to actually like read through the puzzle sheet and make sure that you are like familiar with the class puzzle, or like whatever class that they gave you, just so you know like what's private, what's public, all of the stuff that you have available. But even if you didn't, we'll still be able to answer this, and then we can reference the sheet. So by looking at this, I'll see that here we would be using a member variable, and here we would be using a getter. And usually with member variables, they would end up being private. So we wouldn't be able to access them just by doing puzzles at 0.text. So basically, we can look back at our puzzle sheet. So looking at our puzzle, we'll see that text is a private member variable, so we cannot actually access it by using the dot operator like we suspected when we were looking at the question here. And then if we look, we'll see here that we have this getText function, which returns the text. That's going to be the getter that we want to use. So we're going to end up not wanting to do A, and C would be our correct answer. Okay, 18. Which of the following is a valid statement to call the member function verifier given the following declaration? And we are given the declaration puzzle my puzzle equals puzzle. So that would be creating a default instance of our puzzle class called my puzzle. So first, let's look at the verifier function. So it requires nothing, it modifies nothing, and the effects are that it returns true if guess is equal to solution and returns false otherwise. It will return a bool, and it takes in one parameter, which is a string. So looking at these, first, I see that we're calling verifier using the dot operator on just the class puzzle, and we're not able to do that. We want to do that on our actual instance of my puzzle. So that's not going to be correct. We would want it to look more like my puzzle dot whatever function we wanted to call. In this case, it's verifier. And then remember, we need a parameter, but it would want to look something like this. So B does look very similar to what I just wrote out. The only thing is, remember that whenever we looked at this verifier function, it took in a string as the parameter. So we're not passing anything in here. So B is not going to be a valid way to call verifier. And then C, we are using mypuzzle.verifier, which is correct, and we are passing in a string, which is what we wanted. So C looks like it's going to be the correct answer here, but let's rule out D. So we're doing mypuzzle.verifier equals guess. We can't set a function equal to a data type, so this wouldn't work anyways. But also just remember that we needed to pass in a parameter of string, and that's not how we do that. So D is ruled out as well. So C is going to be the correct answer for this question. Okay, 19. Which of the following is/are fully correct to modify member variables text and solution of my puzzle declared here? So we have puzzle, my puzzle equals puzzle. This is the same instance that we were just looking at, where we had like up here, like we just had a default instance of puzzle called my puzzle. So we want to modify the member variables text and solution of my puzzle. And remember, when we looked at this puzzle class, text and solution are both private member variables. So we can't modify them just by using the dot operator. So I can rule out answer A pretty much immediately because we are modifying private member variables and we can't do that. And then it looks like our other answers are using the set puzzle function. So we'll look at the set puzzle function in the class declaration on that sheet that was given to us. So it requires that new text and new so in are not, or I don't think that's new so in. I think it's new sol like solution. But it requires that both of those are not the empty string. And then it modifies text and solution. And the effects are that it will assign text to new text and solution to new solution. And then it takes in two parameters, which are string new text and string new solution. So looking at answer B, it does look like we are calling set puzzle correctly. We're using the dot operator to call it on my puzzle, which is good. And then we are passing in two strings, which is what we expect from those parameters based on our function in that class sheet that we got. So B looks like it's probably going to be right, but let's just look at the other ones. So if we look at the other two, I can rule out C because it requires in the set puzzle RME that new text and new solution are not the empty string. So that is not going to be a correct answer. And then looking at D, we can rule it out for the same reason that we just did the other one, because we are passing in empty strings. But even if we were like passing in strings as those parameters, we could still rule this out because set puzzle is a void function, so we cannot call that in a print statement. So this is going to also be an incorrect answer. So B will be the correct answer here. And then question 20, which of the following is a correct way to implement the member function puzzle, just as it would appear in the file puzzle.cpp? So let's look at our function puzzle. Remember that that is just going to be the default constructor. It's a little confusing when you read it just because puzzle is the name of the class, but remember that our constructors are going to actually be the name of the class. So that's how you would like determine that that's what the function that we're looking at should be. And then if we look at the RME for that default constructor, we see that it requires nothing. It modifies text and solution, and then it sets text and solution to the empty string. And then, yeah, so let's put that down there. Look at our answers. So A is not modifying text or solution. It's just returning 0. And so this is not going to be a correct answer. It's not doing what we expect. And then B, we have puzzle text equals empty string. and solution equals empty string. Now, it is modifying text and solution, which is what we expect. But remember that in the problem statement here, it's telling us that it wants us to implement it just as it would appear in the file puzzle.cpp. And so we're not going to be within the class declaration, which means that this is an instance where we would need to use the scope resolution operator. And remember that that is this double colon thing. And that just tells us that whatever this function is, it's telling us that that is a member of whatever this class is. So we can rule out answer B because although it is doing text and solution correctly, it's not doing the scope resolution operator. This would not be how it would appear in the file puzzle.cpp. Moving on to answer C. So it is modifying text and solution, how we would expect, and it is using the scope resolution operator. But remember that also when we use a scope resolution operator, we also have the return type before. Return type. And looking at our constructor, it doesn't have a return type. And this is how you can tell also that it is a constructor. Constructors will never have return types. So we will never put void before we define a function of a constructor. So C is not going to be correct because we put that return type there. And then D looks like it's our only answer, but let's just check to make sure that it is actually what we expect. So it is setting text and solution correctly, setting them both to the empty string. And then we are also using the scope resolution operator correctly because we don't have that return type, but we are still saying that we're within the puzzle class defining the puzzle default constructor. So D is a correct answer here. Okay, so it looks like now we have moved on to our free response section. So feel free to take a break if you need to, pause this video, whatever, but we'll just keep going. So free response 1, it wants us to implement the following function, which reads words from a file and prints the character at index IDX from each word, if index is a valid index for the word. And then it requires that the M file stream is in a good state and is already opened a file. So we don't need to do any sort of file handling, at least not like opening it and closing it within this function. It also tells us in this little note here at the end that we should not open or close any files. So that should also tell us that we don't need to do that handling here. But in case it didn't say that on the exam, you would be able to tell that because we've already said that we've opened it, that we don't need to do that stuff in this function. It's also requiring that index is greater than or equal to 0, and it's modifying in file and cout. And then the effects are that we will read every word from in file, one word at a time. And for each word read, if index is a valid index of the word, so i.e. index is less than the length of the word, then we will print using cout the IDX index character from the word, else we will do nothing. So they also give us this example here for the following test case. They've opened puzzler.txt and then they're passing ins and 1 to puzzler, which is the function that we're trying to define. And if the file puzzler.txt contains the following text, be healthy scroll as and then some numbers, then this function would print the following. Since these are the second characters index of 1 from each word or number in the file. And remember that we're passing in whatever the index is. So in this case, we passed in index 1. So for every word that we read in, we just wanted to look at whatever index 1 was in all of these places, which they're all bolded down here as well. But that's a good example for you to kind of understand why this would work. So the first thing that we want to do is we want to read every word from in file one word at a time. And in order to do that, I need to have some sort of variable that I can read into. So let's make a string variable and I will call it word. I don't need to initialize it to anything just because I'm just gonna automatically read into it. And then I want to read every word from in file one word at a time. So the way that I like to do it, I know that we're going to want to use a while loop just because we're reading until we get to the end of the file and we read in all the words. So I'm going to do while, and then we were passed in file, so that's what we want to read in using. So it'll be while in file reads in this word. And then what do we want to do next? We want to see if index is a valid index in the word. So if, and they gave us that code pretty much too. They gave us that IDX is less than length. So that's what we want to check here. IDX is less than, and remember that word is a string and we can check the length of a string using the length function. So we'll do word dot length, and that will give us the length. So that's going to successfully check if the index is a valid index of that word. And then what do we want to do next? We want to print using cout the IDX index character from the word. So in order to do that, we will print using cout word at IDX. You could also do this by doing like word IDX. That would also be valid. And then is there anything else we need to do here? Else it will do nothing. So it looks like that is the end. So let's close our if and let's close our while. And then this is a void function, so we don't need to return anything. So this is all we need to do for this function. I'm gonna move this out. Okay. So for response 2, implement the game class member function play round below, just as it would appear in the file game.cpp. So if we look at the RME that they give us, it requires that the index is greater than or equal to 0 and less than num puzzles. It's going to modify cout and cin, so we should use both of these in this function. And then the effects are that we will print the text of puzzle in the puzzles array at index idx, followed by a new line. It will print enter a guess, and then get the line that is the player's guess. And if the player guess matches the solution of the puzzle, it will return true. Otherwise, it will return false. And a note is that the player guess may contain spaces. So this is going to indicate to me that we should probably use getLine. But first, what I would recommend doing, since we know that we want to use the game class and we haven't really done anything with that yet on this exam, let's read through it and see like what it's giving us. So we have the default constructor, we have an add function, we have a play game function, which is the one that we're doing. And then, wait, is that the one that we're doing? No, we're doing playground, never mind. And then we also have private, which we have our puzzles array, which is private. We have the int num puzzles, which is the number of puzzle instances. And then we also have playground, which is what we are currently implementing. So let's go ahead and start working on our playground. So what is the first thing that we need to do here? We want to print the text of the puzzle in the puzzles array at index idx, followed by a new line. So I'm going to want to do that using cout because it told me to use cout and cin here. And then remember that in this game class declaration, we have our private array puzzles, and that is an array of puzzles. So we're going to want to access whatever puzzle is at the index that was passed in here at idx. Puzzles at idx. And then what do we want to do? We want to print the text of the puzzle in the puzzles array. So remember that whenever we have an array of a data type of a class, that just means that whenever we're looking at like puzzles at idx, that's going to be an instance of a class that we can like use the dot operator on. So because we can do that, I know that I'm going to be wanting to use some sort of member function for the puzzles class to get the text, because remember that text was a private member variable here. And looking at the class definition and declaration here, we have this get text getter. So that's what I'm going to want to use here. So puzzles at idx.get text. And then we wanted to follow it with a new line. Okay, And then what are we doing next? Let's move this. The next thing that we want to do is print enter a guess. So we will also do that using cout. Enter a guess. Did I have a thing? No. Printer, enter a guess. And then the next thing that we want to do is get the line that is the player's guess. And remember that they gave us this note that said that the player guess may contain spaces. So we're going to want to use getLine. In order to use getLine, we need some sort of string to read it into. So let's create a string variable called guess. And then we are going to use getLine to read in the player input into that. And so remember that we are going to pass in cin as our if stream that we're using to read in from, and then guess. So it will read in up until the new line. So it will get that entire line of input from the user, which is great. So we've done steps 1 through 3. And then if the player guess matches the solution of the puzzle, we'll return true. Otherwise, we will return false. So if the player guess is equal to the solution. So let's look at our puzzle class and see how we can check that it's equal to the solution. So we do have our string solution as a private member variable. So we can't just do like puzzles at idx.solution because it's private, we don't have access to it. So what other thing do we have in puzzle that will allow us to check that the guess is correct? It looks like we have this verifier function that will return true if the guess is equal to the solution or false otherwise. So that's what we're going to want to be using here. And we want to use it on that same instance of puzzles that we were looking at. So we can do if puzzles at idx. And then remember that that's our instance, and we're going to call the verifier function using the dot operator. And we need to pass in a string here, and we have a string in our guess variable. And then that's going to return true if the guess is equal to the solution. So we don't need to check anything else here. That will just return true. And then if it's true, we want to return true. And then else, we want to return false. Okay, great. Did we do everything that we needed to do here? It looks like we did. So that's going to be our solution for this free response 2 question. Moving on to free response 3, we want to implement the game class member function play game below, just as it would appear in the file game.cpp. So it requires nothing, it modifies nothing, so we're not going to use cin or cout here. And then the effects are for each puzzle in the puzzles array within the bounds of num puzzles number of puzzles, we want to call play round with the index of that puzzle in the puzzles array. And then if the player won the round, we want to increment a score of the rounds won and print correct plus a new line. And then otherwise we want to print wrong plus a new line. And then after we've done that, we want to print the message, player name, your score is number of rounds won, followed by a new line. And they give us this note that says your solution must call play round. So that is a nice little hint that they gave us there. So let's just look at the game class again to get a nice little refresher on what stuff is going to be helpful here. So we have our puzzles array, which we are going to want to use because they are telling us for each puzzle in the puzzle array. So we're going to want to do that. And then we also have this num puzzles private member variable, and that is the number of puzzle instances, which is already added and dealt with for us. We would assume that it's done for this function. So that's also going to be useful because we want to be within the bounds of num puzzles number of puzzles. So that's going to be something that we want to use. And then we want to use play round. And to do that, we need to pass in the index of that puzzle. So let's go to our play game function. So the first thing that we need to do is for each puzzle in the puzzle array, we're going to be calling play round and all of that. But remember that we are going to want to be incrementing the score here. And we want to do that outside of our for loop. Otherwise, it'll just get redefined to 0 every time. So we want to make sure that we have this variable to keep track of the score outside and set equal to 0. And then we can go through all of the puzzles. So we're going to want to go from I at 0 up until num puzzles. And remember that we are within the play game function, which is a member function of the game class. So we're able to just call or just access our private member variables just by name. So we're allowed to do I is less than num puzzles to check that. And then we want I to increment by 1 every time. And then we want to call play round with the index of that puzzle in the puzzles array. So let's do that. Let's just take a look at play round. It's returning a bool to see if the player guess matches the solution of the puzzle, which is going to be like if they won that round. So we are going to want to keep track of that. So we want to check if play round. And then remember that we're passing in the index of the puzzle that we're doing, which is just going to be I, and that will return true if they won or false otherwise. So if they won, what do we want to do? We want to increment the score. So that'll just be score plus plus. And then we also want to print correct plus a new line. So let's do that. Okay. And also it looks like the army for this is not correct because it says that it should be modifying nothing, but we are printing, so we're going to want to use cout. But if you saw something like this on there, I would just like ask your IA if that was correct. But if it's telling you to print, you should use cout or whatever stream that they gave you. So in this sense, it looks like they just made a little mistake, but that's okay. So we're printing correct and then a new line. And is there anything else we want to do if they won? Nope. And then otherwise we want to print wrong. Plus a new line. Okay, so we've done that. Is there anything else we need to do in our for loop? Nope, it looks like we did everything there. So we can go ahead and close our for loop. And then the next thing is we want to print the message, player name, your score is the number of rounds that they won, followed by a new line. And we see that we have this string player name parameter passed in, so we can use that. So we will print cout player name, which is their name. And we want to print your score is. Remember to keep the spacing correct. So like we would want a space before that since we just printed their name. And then we would also want a space after that. And then I'm just going to continue this on to the next line. So the next thing is the score, which is the number of rounds that they won. And we're keeping that in our score variable. And then we want to follow it by a new line. And then do we need to do anything else here? Nope. And we did call play round. So everything that we needed to do in this function, we did, and it's void, so we don't need to return, but it would be okay if you did. Okay, and moving on to our last free response, we're in the home stretch for this exam. Now it wants us to write statements to use the game class below as specified by each comment, and it wants us to write our solution statements immediately below each comment. So it's telling us to assume that the puzzle variables P1 and P2 have been declared and initialized, and then write a statement for each of the comments below. So they want us to declare one game variable that must be named. Oh my goodness, so sorry. I don't know why I keep stopping screen sharing. Give me 1 second. Okay, just okay, cool. We're back. So we want to assume that the puzzle variables P1 and P2 have been declared and initialized, and then we want to write a statement for each one of the comments below. So they want us to declare one game variable named G1. So let's go ahead and look back at our game class. We only have the game default constructor. And remember that if we want to just make a default instance, we can just do the name of the class, which is game, and whatever we want. Oh my goodness, is it going to keep doing this? Sorry for the technical difficulties. At least we're pretty much at the end. Okay. Okay, let's keep going. So we want to declare one game variable that must be named G1. So we've put our data type, which is the class, and then we want to call it G1. And that would be all that we need to do for this first instance. And then it wants us to add the puzzle instance P1 to the game variable G1. So the way that we will do that is by using this add function. And to do that, we are passing in a puzzle as the parameter. And so it's a member function of game, and we want to add it to G1. So we will do G1 dot add, and then we need to pass in a puzzle instance, and they gave us the one that we want to pass in, which is P1. So it would just be P1 in our parameters, and that is all we need to do there. And then we also want to add the puzzle instance P2 to the game variable G1, and we're going to do that the same way that we just did that one. So I guess that would just be extra points if you got the first one right, which is nice. And then to do, call the play game function with your name as the argument. So what is the play game function? It takes in a string player name. And so we just want to do the same thing. Oh my God, I am so sorry for the technical difficulties, but this is the last part. So we're basically done. Hopefully it won't do it again. We have like one sentence more to write. So if it could just hold on for a second. Okay, can we all see? Amazing. So what we want to do is call play game on our instance G1, same way that we did it before by using the dot operator. So we will do G1 dot play game. And then with your name as the argument. So I'm just going to pass in a string. Oh my God. Sorry. I don't know what is going on with my iPad right now, but if this doesn't work, it's fine. We basically finished the exam, but hopefully it'll hold out long enough for this. Oh, and now Notion's not working either. Okay, but if I were to do this, then I would just pass in Abby as the string, like how you can kind of see that I started writing it. So it would be G1.playGame and then the string Abby within double quotes. Remember that you need to do that to pass in a string. And then that would be it. So we made it through the exam. And let's just go back to Zoom, stop screen sharing since it's not working. Thank you so much for watching and bearing with me with our technical difficulties. I hope this was really helpful for you in studying, and I hope you have good luck on the exam. But yeah, with that, goodbye.